Hello everyone, Mr. Cruze here with another Algebra 2 review for you. This time, the Quarter 4 review. This is the Day 2 review that I gave to you in class on Monday, alright? In this video, we'll be doing as many of the problems for the Quarter 4 review as we can. Remember, your core test is Wednesday, May 22nd, 2013. You can always tweet me, you can leave a comment in the video, you can email me, whatever it takes for you to do well on this Quarter 4 test. It's designed to help you do better in class, alright? So, number one, we graph y equals 3 to the x. Well, I'm going to make a t-table. And then I have to remember what x values do I use for my t-table. I use -2, -1, 0, 1, and 2. And then you just have to plug those in your calculator to get the y values. 3 to the -2nd is 0.1 repeating. 3 to the -1st is 0.3 repeating. 3 to the 0 is 1. 3 to the 1st is 3. And 3 squared is 9. Okay? Hopefully you can see where I got those numbers. Since there's no shifting, there's nothing being added or subtracted on. This is it. Graph it. -2, 0.1 repeating somewhere there. -1, 0.3 repeating is a little bit higher up. 0, 1. 1, 3. 2, 9 would be, let's see, what is this, 4, 5, 6, 7, it'd be somewhere up here. Make sure your graph actually goes through. So as you can see, pretty steep, okay? In general, your exponential graphs will look like that. Okay, they'll look they'll start off really, really shallow and then get really, really steep, okay, in general. Write an exponential function to model the situation and find the amount after specified time. So we have a population of 98,000, growing 2.3% per year for 10 years. Well, the formula is y equals ab to the x, where a is your initial amount. B, since we're growing, b is going to be 1 plus our rate, and x is time. Okay. So let's see, y equals our initial amount's 98,000. 2.3% is actually 0.023 as a decimal. So when I add 1 to it, it'll be 1.023. A lot of people are going to forget the 1. They ask for the exponential function. Check. We just got it. Now we actually have to plug in 10 years to figure out what the population is in 10 years. Make sure you do the exponent part first. So 1.023 to the 10. And then times 98,000. Be careful how you round. We're talking about a population here, so you can't, even though I have 0.89, I can't have 0.89 of a person. So it's still 123,021. You do not round up. Okay. Number 3, find the amount of continuously compounded. That should signal some alarms for you. APERT. Again, where P is your initial amount. E is a number on your calculator. R is your rate. This time you'll notice you don't have to add 1 to it. And T is time now. Okay. So here we go. A equals P E to the RT. Well, it would be 0.046 as a decimal times 5. I would suggest plugging that in your calculator all at once. So let's see. E to the 0.046 times 5. Keep that all in the same parenthesis. And then times 5,000. If you plug it in your calculator correctly, you should get $6,293 and no change. Huh. It's kind of weird. Usually there's some change. Not too bad. Okay, so remember the difference between these two. APERT and y equals ab to the x. All right. Number 4, write this equation in logarithmic form. 729 equals 9 to the 3rd. Currently, it's in what we call exponential form. So I have to log both sides. Since I want to get the 3 out of the exponent, I'm going to log base 9 of both sides. And you might be thinking, why would I do log base 9 of that? Well, the answer is, what happens with log base 9 of 9? It goes away. It cancels itself out. It's 1, technically. Which means the 3 comes out front, and we're left with log base 9 of 729 equals 3. Ta-da! We're in logarithmic form. That's it. There's no need to solve anything. Okay. Graph y equals log base 2 of x minus 1 plus 2. Well, logs are a little tricky to graph. I can remember how to graph number 1 if they're exponential. That's pretty simple. So if there's some way I can rewrite this log equation as an exponential, then I can make a t-table for it. Fortunately for us, we remember that logs and exponentials are inverses of each other, right? As highlighted by the previous problem, they're inverses. So I can actually switch the x and y. You guys remember switching the x and y from a long time ago, quarter 3 in fact. Now I have to get y by itself, so I'm going to subtract 2. Now that I have the log by itself, I can feel free to bump that base. The base is 2, so that means I'm going to bump it. Okay. These two cancel each other out, so I'm left with 2 to the x minus 2 equals y minus 1. And the last thing I need to do is kick that 1 over. You'll notice I did not combine these. One is an exponent and one is not. Okay, there's the inverse. Okay. Now, let me come over here. 2 to the x minus 2 plus 1. I think we can actually make a t-table for 2 to the x, just like we did in problem number 1 at the beginning of this video. Make a t-table. Okay. And then plug in numbers. 2 to the negative 2 should be 0.25. 2 to the negative 1 should be 0.5. And then 1, and then 2, and then 4. Right? Pretty simple. Now, we have to adjust it, though, because that's not what we want. We want 2 to the x minus 2 plus 1. Well, you remember this adds 2 to your x's. So we're going to take all of our x's and add 2. This adds 1 to all of our y's. Okay? So, let's shift it. Add 2 to all your x's. That means negative 2 becomes 0, and then we just go up from there, right? Add 1 to all your y's. Well, that's pretty simple. This isn't so bad. Actually, these numbers are coming out relatively nice. Okay, so this is the t-table for this graph, but that's not the one I wanted to graph, right? I wanted to graph this one at the beginning. Well, the first step in this problem was I switched the x and y. So guess what the last step is? Switch this t-table, and that'll be the t-table for this graph. Of course, I'm running out of room, but I will switch it for you. 1.250, 1.51, 22, 33, 54. Okay. This is what we graph. This is the t-table for this. 1.250 is right there. 1.51 is right there. 22, 33, 54. In general, this is what your log graphs are going to look like. They're going to kind of look like a sideways hook, I think they look like. Alright? I think, honestly, this is the hardest one on the test, simply because there's so many steps you have to do. You have to do the inverse, you have to get y by itself, you have to make a t-table, then you have to shift it, then you have to flip it back. I feel like there's just so many steps there. Okay? Oh, use properties of logs to evaluate log base 8 of 4 plus log base 8 of 16. I remember if they have the same base, and it's plus, then that means that's actually multiplication of the two numbers inside. So it'll be 4 times 16. So we get log base 8 of 4 times 16 is 64. And unfortunately, I can't plug in log base 8 into my calculator, but there's a nice little change of base formula that says I can do log of 64 divided by log of 8. So I just type that in my calculator. Log of 64 divided by log of 8. And you get 2. By the way, for you natural log fans, you can also do natural log of 64 divided by natural log of 8, and you still miraculously get 2. Okay. Number 7, use the properties of logs to evaluate. Same thing, same base, only this time it's minus. Well, if addition was multiplication, then that means subtraction is going to be division. So this will be log base 5 of 24 divided by 3. This first one always goes on top. We can reduce log base 5 of, 24 divided by 3 is 8. Once again, I can't do log base 5, but I can change the base. So I'm going to do log of 8 divided by log of 5. This one will not come out as pretty as the last one. They'll probably ask for 3 decimal places, so 1.292 it is. Okay. So far, so good. Number 8, solve log of 10 minus log of 2x equals 4. If I can get the logs to be the same, then I can feel free to bump the base, but I can't do it yet, not until I have a single log. So subtraction again means division. So we have log of 10 over 2x equals 4. Now I can bump the base. Remember that if they don't write it, it's 10. So we're going to bump that base. The 10 and the log 10, go away. So we have 10 over 2x equals whatever 10 to the 4th power is. And I believe that is 10,000. Okay. I'm going to put 10,000 over 1, and here's why. Because now I can cross multiply. You guys remember proportions, right? 10 times 1 is 10. 2x times 10,000 is 20,000x. And then you can go ahead and divide by 20,000. Whew. That'd be a nice, pretty number. 10 divided by 20,000. Let's see. I get scientific notation here. Let's see. I get 5 times 10 to the negative 4. So it'd be 1, 2, 3, 4. Oh, I'm sorry. Other way. It'd be 1, 2, 3, 4 this way. So it'd be 0.005. So if you were to round to 3 places, it's actually 0.001. Okay? I'm not sure how the numbers will come out on your test, but something like that. Okay? We can do one more. Solve 7 to the 3y equals 45. This is the opposite of this one. I need to get the 3y out of the exponent. So to do that, I'm going to log both sides. Remember, whatever I do to one side, I have to do to the other. Okay? Let's see. This now comes out front. So we have 3y log of 7 equals log 45. I'm going to go ahead and divide by log 7. So that goes away. Anyway, we get 3y equals, and then I'm going to figure out what log of 45 divided by log of 7 is. It's 1.956, roughly. And then we're going to go ahead and divide that by 3 to finish out the problem. 1.956 divided by 3 is 0.652. There's your answer. As always, you can check your answers back in those if you're not quite sure. Okay? I think that'll be it for this video. We'll continue on in the next one. Continue to study. Again, you can leave comments on this video. You can always tweet me. You can email me. You can do whatever it takes. All right? Good luck studying, and I'll see you tomorrow.